Okay, so good morning, everyone. When you join us, you can basically type up your name so that we can start. Okay, so let me just share the link. Okay, so let me just share the link so that you people you can start joining us. Okay, 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 okay. Okay, so we can start. So you can start joining us as we are starting. I've shared the link in the group. So make sure you start joining so that we finish up the remaining concept. Remember, we started something very, very important. So we did, that was redox reactions. Okay, so that was redox reactions. Okay, that's what we covered. Then we are balancing this stuff. We did, that was balancing. So we did balancing redox reactions in acidic and basic medium. Okay, so this was the coverage of the thing that we did. Then from that we know that we covered one thing. We did what's the definitions of redox and oxidation of reactions, and also the reduction and oxidation of reactions. Then after that we did how to assign oxidation numbers. Okay, oxidation numbers. Then after this, we also covered the balancing. Okay, balancing in acidic medium. Okay, balancing in acidic medium. Then what was left is balancing in basic medium. Okay, so media. Okay, so this was the remaining concept. So this is our main focus for our lesson. So if you're able to get me, you can just type up that I'm audible enough for everyone to get me properly so that we proceed. And then the other thing I want to emphasize on is that we have to make sure that you watch this video and understand it at all. So then this video will make sense. You have first to watch the previous video that we did on the remaining stuff here. For this stuff here, definitions, assigning oxidation number, and how to balance in acidic media. Like I told you that you can't balance in basic media if you haven't balanced in acidic media. So the process also starts from first someone should know how to balance in this one here, then we can balance here. So you need to watch the previous video. So I'll put the link of the previous video in the comment section when I upload the video to YouTube there, so that those that didn't attend the previous lesson, they can first watch the video for the previous lesson, so before we proceed to this one. Okay, so let's start now. We are going to proceed. So let me just start on the first page. Okay, so we are doing balancing in basic. So just from the name basic, this one is very basic media. Okay, so from the name basic, we can know that it's very simple and very basic. Yeah, so what are the steps that we follow? Or in short, we can say the rules. So it's very simple, very simple. So one is that first, balance in acidic medium. So mean, like we said, we cannot balance in basic medium before we balance in acidic medium. Then after you balance in acidic medium, is that after you balance in acidic medium, do the following. Yeah, so A is that we need to add appropriate. Okay, so add appropriate number. So can someone type up number of what? Add appropriate number of what? Can someone type up? What do we add? Add appropriate numbers of what? Someone type up so that we proceed. Waiting for your answer from you guys. Add appropriate number of. Okay, good. Hydroxide ion. So we add appropriate number of. So not hydrogen ion, but hydroxide. Okay, hydroxide ion. In brackets, we write its chemical form symbol. So this is hydroxide ion. It's having a negative charge on top there. Okay. So we add appropriate number of hydroxide ion to both sides of the chemical equation. Meaning you have to add both the reactant side and to the product side. We add hydrogen ion. Then after you do that, we go to step 3, which will be, I think, the last one there. We have to understand one important concept in your mind, that if you have hydrogen ion plus hydroxide ion, when hydrogen ion react with hydroxide ion, what do we produce? We produce water molecules. So in this case, we have one hydrogen ion and one hydroxide ion. We have also produced one water molecules. So in the case we have, let's say, 10 hydrogen ion plus another 10 hydroxide ion, we should also expect to get 10 water molecules. So always, if you balance your equation, you find it happen that maybe you have 4 hydrogen ion, then 3 hydroxide. These numbers, they are not matching, meaning something is wrong with your calculation. You have to check. So number of hydrogen ion and number of hydroxide ion have to be same. From this concept, you can tell we add appropriate number of hydroxide ion, so appropriate to hydrogen ion. So the number of hydroxide ion to add depends with how many hydrogen ions are present in the balanced equation in acidic media. Because when we balance in acidic media, we expect hydrogen ion to appear in the final answer that we get. So the number of hydrogen ion that will appear in the balanced equation in acidic media will determine how many hydroxide ion are going to add. So if you have 1, we have to add 1 hydroxide ion. If you have 10, we add 10. For example, maybe if you have 4 hydrogen ion, then also 4 hydroxide ion, we expect to get 4 H2O. So this is a concept that you should know, that whenever you happen to have hydrogen ion and hydroxide ion to the same side in the particular reaction, they react to form water. Yeah. So after that, we go to step 4, which is the last one, just to cancel out what is common. And that how it is done, meaning we are done. So what we do, the steps, let's say, recap again. We say step 1, first you have to balance in acidic media completely. After that, we focus on the number of hydrogen ion present. So we focus on the number of hydrogen ion present in the balanced equation in acidic medium. Then when you notice how many they are, we are going to add appropriate number of hydrogen ion depending on how many hydrogen ion are present. So we add hydroxide ion. After that, if at all, we are going to find that if the moment you see that hydroxide ion and hydrogen ion, they are appearing to same side, combine them to make water. After that, check for anything in common and cancel out. If nothing in common, nothing we can cancel, just end from there. So we only cancel if anything appears to be in common. Okay, good. Okay, so let's now do the question. So are we together? Can I proceed to an example? So we are going to proceed with the same example that we did. Well, so because that one you already balanced. So the question that we did was, let me just write the question here. So if anyone have got a question, you can type up before we proceed, and then I'll check and I'll respond. So the question is here. It's an exam question as well, the same one that we did. It was the balance the following. Balance the following. What is the following reaction? Okay. The following reaction following a reaction ionic in basic media. Okay, basic media. So the reaction was this one here, then O4 minus, then plus I minus. We are getting this side MnO2 plus I2. So that was 8 marks. Okay. So they want us to balance this reaction in acidic medium. Okay. Or in basic medium. So we have to record the steps. We know step 1, we have to balance in acidic media. After that, we can balance in basic medium. Now that if you remember very well, this is the example that we did in the previous video. So we already balanced in acidic media. So we're going to jump all the steps for acidic medium, then we just do for the basic medium. So we know step 1 is first to balance in acidic media. But we already balanced. Our answer was, which was here. Let me just type it, write it down properly here. The balanced one was 8 hydrogen ion, then plus 4 MnO4 minus, then plus 6 iodine. Then this was producing 2 MnO2, then plus 4H2O, then plus what? 3I2. Yeah, so this was the balanced equation in okay, so I think I've seen some question there. Okay, let me just check here. Okay, so if you have any question, you can ask. So those with questions, feel free, ask it so that we move together. The most important thing is make sure that you understand. Yeah. Yeah. Okay, so let's proceed. Yeah. So we already, this was the balance, meaning step 1 we already covered. So what we do, we go to step 2, where we say we add appropriate. So we add appropriate number of hydroxide ion, okay, to, very important, to both sides. Okay, so we're going to add here and this side. Then we say the number of hydroxide ion to add, it depends on the number of hydrogen ion that we have. So how many hydrogen ion do we have in this particular reaction? How many hydrogen ions do we have in this particular reaction? Type up quickly. There are how many? So how many hydrogen ions do we have in the balanced acidic medium reaction? 8. Good, Jerome. So we have 8. There are 8. So meaning we have to add 8 hydroxide ion to both sides of the equation. So I'm going to say, you can put it at end point. So for me, I can put them here. I'll say, okay, 8 hydroxide ion minus there. Then we put everything the way it is. So we're going to plus again 8 hydrogen ion, which was already there, and then plus 4MnO4 minus, then plus 6I minus, then this is producing 2 MnO2 plus 4H2O plus 3I2. So with a space, I'll put this guy here, the 8. So don't forget to put a charge in. So this is what we have. So we have added 8 hydroxide, comparing to the 8 hydrogen ion. But like I told you that whenever you see hydrogen ions and hydroxide, these two guys, they are friends. Whenever they see, they couple together and form H2O. Okay, so this, they will react to form water. So how many water molecules are going to get from here? We have 8 hydroxide and 8 hydrogen ions. So how many water molecules will be formed from this? Type up quickly. How many water molecules will be formed? Okay. So how many water molecules are we going to form when we react the 8 hydroxide ion and okay, 8 water molecules. Good. Yeah, so we're going to form 8 water molecules. Yeah. Okay, so we're going to produce 8 water molecules. So we can add these two. So this one will give us, I'll use red ink to differentiate. So we're going to get 8 H2O. Okay, then the rest we can write in, let me just write it a bit down. So it's 8 H2O. Then the other thing will remain the same, plus, so these are formed water, plus 4M NO4 minus, then plus 6I minus, this is giving us 2M NO2 plus what? This is 4H2O. So this 8 hydroxide ion to the product side, they don't have hydrogen ions to react with for it to form water. So it will remain the same thing. So you see here, it's remaining same thing. This one is simple because we don't have hydrogen ion here. To the product, to the reactant side, we had hydrogen ion and hydroxide, possible to make water. But to the product side, we only have hydroxide ion. The partner is not there. So this one will remain single, like you. Yeah, so let's proceed now. So we have formed water. So if you remember very well, one of the steps that we talked about was that okay, maybe I've lost the paper where I wrote. Just okay, let's say about here. Okay, so we said that when we balance in acidic meter, we have to add hydrogen ions. Hydroxide ions. Yeah, so when you add hydroxide ion, we are going to, on one thing we can form water because hydroxide and hydrogen, they are partners here. By this side, this one I've got no partner, it will remain single. Then after this, we have to check to what is common and cancel out what is appearing to both sides. So if you check here, we have 8 water molecules, we have 4 water molecules. Water and water are the same things. So meaning the smaller will go, the bigger will be reduced. Okay, so we're going to say these all 4 water molecules will be cancelled out. Then from 8, we are going to subtract 4 water molecules. Okay, so what is 8 water molecules minus 4 water molecules? What will remain is basically 4 water molecules as well. So meaning this is the only thing that is common. If you check, we have manganese oxide here. It's not similar to this. This is 2, this is 4, so they are not the same. Okay, so after this, now we proceed to write the new equation. So the new equation will be 4H2O, then plus 4M NO4 minus, then plus what is okay, plus 6 this way, and then this will be 2m NO2. The water cancelled, remember, so it's not no longer there, plus what 80 hydroxide. So let me just write this one here, very, very important. Hydroxide ion here. So after this, let's check if everything is balanced. So how many hydrogen are here? We have 4 times 2, we have 8 hydrogens. Then how many hydrogen are here? They are 8 as well, balanced. Now how many oxygen are here? So if you check, we have this is 4 times 4. We have 4 oxygen here. If you check, 4 oxygen times the 4 in front, 4 times 4 is 16. 16 plus this 4 oxygen here, which is 20 oxygens. So we come and check here. How many oxygen are here? Is that okay, sorry, we made a mistake. This is 2, sorry. From the balanced equation, this was 2. Okay, not a 4. So it's a 2 here. Yeah, so if you remember very well, it's a 2, not 4, okay? Yeah, it's 2, not 4. Yeah, so this is 2. So let's now count properly. So we are saying we have 8 hydrogen ions. Then we have how many oxygen? This will be 2 times 4. That will give us 2 times 4 will give us 8. 8 plus 4, that will be 12 oxygens, okay? Then we come here, we have 8 oxygen here. Then 2 times 4 is 8 as well, also 12 oxygen this side. Fine. And then manganese, we have 2. This side we have 2. Then iodine, we have okay, plus the 3I. We didn't forget that. Hydrogen, we have iodine, we have 6 here. We also have 3 times 2 here, which is 6. Meaning everything is balanced. So this equation is done. So meaning this is our final answer now. We have 4H2O plus 2M NO4 minus plus 6I minus. We are producing 2M NO2 plus 8 hydrogen hydroxide ion. So due to lack of space, I'll put it here, plus 3I2, meaning we are done, because the presence of hydroxide ion is basically telling you that the reaction is in acidic basic medium. Remember, a base is a compound that when dissolved in water, it produces hydroxide ion as the only negatively charged ion. So the appearance of this hydroxide ion and checking that everything is balanced is telling us we have achieved our goal of balancing the reaction in as basic medium. So this reaction now is balanced. So this is how we do it. So any question, or do you need any extra example, or it's fine just like just this, it's okay, or you need an extra example? So let me know if we can do an example. We are rushing for classes, for lectures and all that, or can we do 1 or 2 examples? Okay, so any question, or do you need extra example, or just that it's all right? Which ions? We mean electrons or what? Meaning everything is done from them. So just know that when doing in a basic medium, we first have to balance in acidic medium. After that, step 2, we add appropriate number of hydrogen ions or hydroxide ions, and then after that, water has to be formed somewhere. Then we cancel out if there is anything in common. Well, the moment you cancel out, that will be the end of the story. So when you cancel something, that's the end of the story. So that's the main step that we have to do. Yeah, so another question, or maybe you need something like another example. Quickly, so that we proceed. If there is anything, we do an example, and then we can go it a day. So any question or any extra example, which one is which? Any question or extra example? Okay, give another example. All right, so let's proceed. Let's do the last example. Let me just look for the question. Okay, let me just find the question somewhere. Okay, just a minute. Let me just look for the proper question that we can solve. Unfortunately, I can't get one from here. Okay. I think I have a very nice question here. Okay, so here is a question now. Okay, so it's the last example that we're going to solve. It's an exam question as well. So question is here. Balance the reaction in basic media. So the reaction is Cr2O7 minus, then plus HNO2 producing Cr3 plus, then this is plus NO3 minus there. So they have given a state symbol. This is aqueous, also aqueous, and aqueous. So this is 10 marks question. So balance the reaction in basic medium. So this is what we have. So we know that first thing we have to balance in yeah. So Jerome, your question is you're correct. Just that. So for acidic medium, all you do is to balance in for basic medium, all you do is to balance first in acidic media. After that, we add hydroxide ion. Then water has to be formed somewhere. Cancel out what can be cancelled. The moment we cancel, we are done. Just that. Good. So yeah, so we do it like that way. So let's begin and finish up our work. So solution. So we know that number one, first we need to balance in acidic medium. Okay, so we know that when balancing in acidic medium, one of the steps was to assign my hands to assign oxidation number. Okay, oxidation numbers of all uncommon elements except hydrogen and oxygen. So we are going to rewrite our reaction here to the Cr2O7, which is dichromate, plus this one here, O2, then producing Cr3, Cr just 3 plus, then plus NO3 minus. So here we know that for oxygen we can't calculate, but we need to calculate for chromium. So we're going to say that the overall charge is positive, -2. So we're going to say that 2 chromium plus 7 oxygen, the answer should be -2. But we have information about oxygen that the oxidation number of oxygen is always -2. So we replace that. So it'll be 2Cr plus 7 minus 2 is equal to -2. So the -2 in bracket here is for oxygen. The -2 here is a product of, or the sum of the oxidation numbers of all the elements here. So we have Cr2, then this is minus 14 is equal to -2. So like term together, Cr equal to minus 2 plus 14. So 2Cr is equal to positive 12. We divide by 2, we divide by 2, meaning Cr is equal to positive 6. So we have assigned for this one here. Now we come to the other guy here, which is HNO2. Yeah. So we have to assign for nitrogen, because we know for hydrogen it's always a positive 1, except in binary ionic compound where it is a -1. Then for oxygen it also always -2. Hydrogen always positive 1, then oxygen -2. So we're going to say hydrogen plus nitrogen plus 2 oxygens. What's the overall charge? We don't have any number on top, meaning it's a 0, right? So nitrogen, we know, hydrogen, we know that it's a 1, plus nitrogen, the one we want, plus 2 that, then -2 equal to 0. So the -2 we are putting here is the oxidation number for oxygen. It's a standard, never change. So that you should know. After that, we get 1 plus Cn minus 4 equal to 0. So what is 1 minus 4? It's -3. So I have N minus 3 equal to 0, meaning nitrogen is positive 3. So we have also assigned for nitrogen there. Now we go to the other part, to the other side, we have now chromium here, 3 plus. So chromium, no need to calculate, it's already given, it's only have a single. So like we said, there's a rule which said that the charge on top of the element or a compound indicates the overall charge of, or the overall oxidation number. So we have chromium with a 3 plus on top, meaning in this case it's positive 3 for chromium there. Now we go to the last part where we have this one here. Yeah, so we have to find for nitrogen in this case. So this one will be that N plus how many oxygen? 3 oxygens. Overall charge, we have a negative there, which is -1, meaning it's equal to that. So meaning we guess N plus 3. Oxidation number for oxygen is -2 equal to -1. So this will be N is equal to -1. We know that if you multiply this, you get positive 6. Look, 3 times -2 is -6. -6, when you go to the other side, you become positive 6. Okay? So this will be N is equal to positive 5, because -1 plus 6 is positive 5. So we are done assigning oxidation numbers. Yeah. So we can now go to the next step after we are done assigning oxidation numbers. So next step we said is to identify which reaction is a reduction and which one is the oxidation of reaction after assigning. So to identify which reaction is the reduction and which reaction is the oxidation, remember we use definitions. Yeah. So let's proceed. So I'm going to rewrite our equation here, which is CR2O7 minus, then plus what? This is N, like that. Then O2, we are getting CR3 plus, then plus what? N. Okay, there is no H, just NO3 minus. Yeah. Okay, so we have calculated chromium, we got positive 6 here. Nitrogen here was positive 3. Then chromium this side is positive 3. Nitrogen this side was positive 5. Yeah, this is what we calculated. So now let's rewrite it properly. So we have CR2, then O7 minus plus HO2. We are getting CR3 plus, then plus NO3 minus. So we are saying that this is positive 7. This was positive 3. Okay, positive 3 there for nitrogen here, for chromium there. Then this is positive 3 as well. So we can maybe put it on top there. Okay, positive 3. Then this is positive 5. So positive 3. Now we start comparing chromium here to chromium that side, and nitrogen here to nitrogen this side. What happened? So if you check properly, we say chromium initially it was positive 7, then it became positive 3. So this, we can see that there is a decrease in oxidation number from 7 to 3. So, and we know that decrease in oxidation number is called reduction. So the definition now has helped us to identify that there was a decrease here from 7 to 3. There's a decrease. So meaning this one is our reduction reaction. Now we check from here, from 3 to positive 5, there is an increase by 2, meaning 3 has become 5. So an increase in oxidation number is called oxidation. So this is oxidation. So now we can split the two half reactions. So we can say, okay, my reduction is here. Then our oxidation has to be this side. Okay, so our reduction is CR2O7 minus there. Then it's producing what? Just CR3 plus. Okay, then the other one, this is our reduction. Yes, now our oxidation will be HNO2. We are getting NO3 minus. So we have splitted the two-half reaction. Okay, we have assigned the oxidation number. We have identified which one is reduction of reaction, which one is oxidation of reaction. Again, we have also splitted the two-half reactions. So what is remaining now is to balance the things. So remember what I said, you have to balance all the elements except oxygen and hydrogen. Okay. So if you check here, we have now to balance all the elements except oxygen and hydrogen. So if you check, we have 2 chromium, we have 1 chromium. So we can put a 2 here to balance it up. So the reason why we don't balance oxygen using numbers and hydrogen, you can check in this case, we have 7 oxygen here, By this side, we don't have anything like oxygen. So there is no way we can put a number here to get 7 oxygen that we don't have, because we have 0 oxygen. So whatever number we put here, say that number multiplied by 0 oxygen, we get still a 0. So the principle behind why we don't use numbers to balance oxygen and hydrogen is that in some reaction, we can only have oxygen to one side, then the other side we don't have anything like oxygen. Then in that case, it brings a confusion by balancing using numbers. That's why the people that used to discover this, they said that we don't have to use a number to balance oxygen, because in some reaction, oxygen can be absent to one side, or hydrogen can be absent to one side. So using the number will become that difficult. That's why we use water. Yeah. Then this side we have nitrogen 1, nothing to balance. Okay. So now we can balance water, or we can balance oxygen. So now let's try to balance oxygen. Okay. So this side we have 7 oxygen, we have no oxygen here. So to balance that, we're going to add 7 water molecules here. Remember what we said, to balance oxygen, we use appropriate number of water molecules. So this will be Cr2O7 minus, and then this will give us the 2 Cr3 plus, then plus 7H2O, because we have 7. Oh, okay. So 6 electrons here. Thank you for that. It's 6. Yeah. But still, it remained the same. From 6 to 3, this is a decrease. Thank you for that correction. You have 6 electrons. 6, then 6. Okay, good. Okay, thank you. Yeah, so 6 electrons. Good. Yeah, then this side, we have 2 oxygen here and then 3 oxygen here. So we have more to the product and less to the reactant. So we need also to have 3 here. So meaning we are missing 1 oxygen. So we're going to add 1 water molecule this side. So we say HNO2 plus just 1 water molecule, which is H2O. Then this O thing should give us NO3. So we can see that we have 2 plus 1, 3 oxygen. 3 oxygen. Oxygen now is balanced. So we have balanced oxygen. Yeah. So after balancing oxygen, now we have to balance hydrogen. So in the time we are balancing oxygen, we are creating a problem of putting hydrogen ion, which wasn't here. So we need to balance it up. So we say to balance hydrogen, we use, so now we say balance hydrogen using hydrogen ion. Okay. So we should know the difference between hydrogen and hydrogen ion is that this is hydrogen, but this is hydrogen ion. They have got a charge. So hydrogen ion, the one with a charge on top, then hydrogen ion is chargeless. Okay. This hydrogen ion. Good. So let's proceed to the next step. I just need to copy this reaction, which is okay. I'll just write it here. So we have control. So we have Cr2O7 minus 2, then plus, oh sorry, then just start properly. So I have the reduction this side. So it's the reduction. We have CR2O7 minus. Then we are getting 2 CR3 plus, then plus 7H H2O. So meaning we have to add even 6 H2O because we made a mistake. Okay, 7, correct. So sorry, 7, yeah, fine. Then this side we have the oxidation, which is HNO2 plus H2O. We are getting NO3 minus. So we say we have to balance the hydrogen ion. So we have saved 14 hydrogen here. 7 times 2 is 14. We have to add 14 hydrogen on this side. So we're going to say 14 hydrogen ion plus whatever we have here, which is CR2O7 minus 2, producing 2CR3 plus, then plus 7H2O. Okay, so this is our new reduction. Now we come here. We have 2 hydrogen ion here. Then we have 1 hydrogen here. We have 2 hydrogen, 1 hydrogen here. Oh, 2 hydrogen plus 1, which is 3. Meaning we have to add how many this side? 3 as well. So we are going to get NO2 plus H2O, giving us NO3 minus, and then plus what? 3 hydrogen ion. So if we are to count, we have 1 hydrogen plus 2, 3. This side 3 hydrogen ion balanced. So this is now our new oxidation. So far we can check that we have balanced all the elements. We have balanced oxygen, we have balanced hydrogen. Okay, so after that, what is next? Now we need to calculate the number of electrons. So we need to calculate the number of electrons that was, number 1, gained in the reduction half reaction. The number 2, lost in the oxidation half reactions. Okay, so that's where we are now. We have to calculate how many electrons was gained in the reduction half reaction and how many electrons was lost by subtracting the difference. So we basically just do the subtractions. So let's now proceed. And remember what I told you, that for the reduction half reaction, the number of electrons gained, we add them to the reactant side. So R. Then for the oxidation, it's to the product side. So when you know for the other one is so simple. So for the oxidation now, we put to the product side. Yeah, so let's proceed. So any question? Are we together? We proceed? Or maybe someone have got a question. So if you have a question, just ask it. I've given 1 minute for questions. So If you are together, just say we are together so that we proceed. But if you have a question, ask. No questions, eh? Okay. Okay, I'll keep checking if anyone will type up a question, but let's proceed in the meantime. So, okay, let me do this. So let's proceed. So let's go. Our reduction is here. Our reduction of reaction is here. We have it was 14 hydrogen ion plus Cr2 O7 minus. Then this was giving us 2 Cr plus 3 there, then plus 7 H2O. Okay, so then if you remember very well, chromium was positive 6 electrons, and then after the reaction we got them positive 3. Yeah, it was positive 3. Yeah, positive 3. Yeah, it's positive 3 here. So now you have to compare the difference. So you have to subtract. What is 6 minus 3? So 6 minus 3 is equal to 3 electrons. But now this is where your friends makes mistakes, because they don't pay attention to particular details. We have 2 chromium here, 2 chromium there, meaning that this 3 electron that we have calculated are the one that was I'm not seeing you right. What you are writing? Oh, on top there. So what we do, the one who has, if you're unable to see what I'm writing on top, just click on your screen. Then you'll be able to see, so that you see the full screen of the presentation. Click on the screen so that you just move. Click on the screen, then you'll be able to see what is on top there. And let me know if you'll be able to see what is on top. But okay, I'll start now writing down. So Aurelian, click on the screen, then you'll be able to see what is written on top. Okay, so here now is why it gets interesting. We have 2 chromium, 2 chromium. So the 3 electrons are the one lost by 1 chromium. So we're going to say that the total number of electrons lost, total number of electrons gained. So total number of electrons gained is calculated as follows. That's going to be number of chromium that we have, number of element. We have 2 chromium times number of electrons. So since we have 2 of them, so I'm going to say 2 multiplied by the number of electrons, which is 3. So we're going to get 6 total electrons, which was gained. So this is very vital. Okay, good. Yeah, that you're able to see now. Yeah, so 6 total electrons are the one that was lost. It's because we have 2 chromium, so each chromium was losing 2 electrons. For example, you can say if you guys are 2 of you, and then they say that you go to the market, each one of you spend a 10 kwacha. So if you say, oh, what's the total amount of money that you spend to the market? It has to be 10 kwacha multiplied by the how many you owe. So we are 2, and each one was able to spend a 10. So say 2 times 10. Then you get a 20 kwacha. It's the total money that you spend. Same here. we have two chromium, then each chromium is able to receive 3 electrons. So meaning the total number of electrons that was received here has to be 6 because there are 2. So if there are 10, you say 3 multiplied by 10, meaning you're supposed to be 30 electrons. Okay, so that's what we do. So meaning these 3 electrons has to be added to the reactant side because this is a reduction of reaction. So now let's write our new equation will be 14 hydrogen ion plus Cr2O7 minus, then plus the 6 electrons now. Okay, very important. Then this producing 2 Cr3 plus 7H2O. Yeah, so we have done. So meaning this is now our also new reduction. Of reaction. Okay, this is our new reduction of reaction. So after this, now we come to the oxidation of reaction. So let's now balance the oxidation. Of reaction. So our oxidation of reaction, where is it? Okay, it is here. It is it's HNO2 plus sorry, so plus what? Water molecule H2O here. Boom, boom, boom. Maybe something different there. Okay, so plus this is producing NO3 minus plus 3 hydrogen ion. Okay, so now if you remember very well from where we started, this one, oh sorry, hey, okay, this one was positive 3, this one was positive 5. Okay, so I have to check again the difference. So from here to this side, what's the difference? There is an increase in the oxidation number by how many? So it's a 5 minus 3. The answer is 2. But now we check it. We only have one nitrogen. So 1 nitrogen multiplied by 2, we just get a 2. Meaning in this case we just had 2 electrons here. So we are going to get HNO2 plus H2O producing NO3 minus plus 3 hydrogen ion, then plus 3 electrons. So you see, electrons remain the same 3 because we only have 1 nitrogen. So 1 nitrogen lost 3 electrons and it ended there because nitrogen was alone in this particular reaction. It was not like doubled or anything like that. Okay, so up to this point, can we proceed? Or any question, just type up. If you have a question, we need to move together so that you get the concept. That when you go to the document, you don't have the challenges to understand. Even as the same thing, if you go in your test, the main important thing that you go there and do the very best. And you can only do the very best if you have understood the concept from here. So I have to take our time to make sure that you get everything possibly. So if you have any question, ask or we proceed. So just say we are together so that I know that everyone is fine so that we can continue. Okay. So we can say this is our new oxidation. Okay, good. So let's proceed. Yeah, so this is our new extension. Now that we have balanced everything, so let me just rewrite them this side so that we focus on them at good. So we start with the reduction here. So some people they are not able to see that, so we say reduction here. Reduction half reaction. So when I write x Rx, I mean reaction 9. Yeah, we have 14 hydrogen ion plus Cr2 O7 minus there, then plus 6 electrons, right? So 6 electrons, then we are getting this side 2Cr 3 plus, then plus 7H2O. Then let's come to the other one for the oxidation. Half reaction, we have a different story. So we have NO2 plus H2O. This is giving us NO3 minus, then plus 3 hydrogen ion and plus 3 electrons. So in this reaction, we can say that we have balanced hydrogen here, we have balanced chromium, we have balanced oxygen. We have also added the electrons to the reactant side because it was a reduction and all that. Even here we have balanced all the nitrogen, the electrons we have added and everything. Nitrogen, and hydrogen and oxygen are all balanced. Yeah, so even if we are to check, we have 2 oxygen here plus 1, this is 3, and the 3 oxygen. 1 nitrogen, hydrogen, we have 2 here plus 1, 3, also 3 here. So now, remember what I told you that we have now inter-reaction balance of electrons. So what we call now inter-reaction balancing of electrons. So you see that electrons in both half reactions should be the same, so that when cancelling out, they all disappear because we don't need to have electrons in the final equation. So we have 3 electrons here, we have 6 here. They are not balanced. So like we said that the number here should multiply this one multiply the other one. But in this case, you have to look to the lowest common multiple between 6 and 3. Is basically 6, because 3 can go into 6 and then 6 can go into itself. So in this case, the best thing to do is that we can just multiply this one by 2 so that we get 6 electrons, achieving 6 within here. So you can tell between 2 and 3 and 6, 3 can go into 6 and 3 can go, and 6 can go into 6. So if we achieve 6 electrons, we'll be fine. That's the lowest common multiple between the two numbers is 6. The lowest number in which 6 and 3 can go is basically 6. So meaning we need to have 6 electrons. Of course, we can multiply this by 6, this by 3. By that will be just too big. So you have to think of the lowest common multiple. So meaning all we do is just to multiply this reaction by 2 so that we achieve 6 electrons there. So we are going to get this. We're going to have HNO2 plus H2O, then this will get in NO3 minus plus 3H plus 3 electrons there. So all the equation will be multiplied by 2. So we're going to have this will be, we get 2 here, then HNO2 plus 2H2O. This will be giving us again 2 NO3 minus, then plus what, 6 hydrogen ion, then plus 6 electrons. So we have now 6 electrons, so meaning interaction balancing of electrons is now achieved. Okay, so we have balanced the reaction balancing of electrons. So in this case, so meaning we have balanced everything. So now we can add the 12 reactions. So we have balanced all the elements. We have balanced hydrogen. We have balanced oxygen. We also balanced the electrons. So in this case, we can add the 12 reactions. Remember, I told you we focus on balancing one or elements. Then also balance oxygen. Also balance hydrogen. Then number 4, balance electrons. So these are the 4 main things that redox reaction rely on. Balancing of these things, all elements, oxygen, hydrogen, and electrons. And we balanced all the elements. We balanced oxygen, we balanced hydrogen, and we have balanced electrons. So now we can add back the 12 reactions because we splitted it. So remember the way we add reactant plus reactant, oxygen, then product plus product. So now let's add the 2. So as we add, you're going to do this. So we have 14 hydrogen ion plus Cr2 O7 minus 2 there, then plus 6 electrons. This is from the reduction. Then you're going to put the one from the oxidation, which was plus 2 HNO2, then plus 2H2O, like that, yeah. So because of space, I'll put the arrow like this. But it's supposed to be that now because of space. I put the arrow like this. Then I'm going to put in the other guys here, which is NO3 minus plus 3 hydrogen ion, then plus 2, and this is 6, 6 hydrogen ion here, then plus since we are writing the first one, it's okay, fine. Plus 6 electrons, then plus the one for the other guy, which is 2Cr3 plus, then plus 7H2O. So this is a summation of the 2 half reactions. Now when we add, you have to look to what is common and cancel the spectator ions. So if you check properly that we have 14 hydrogen ion, we have 6 hydrogen ion. So the smaller will go, the bigger will be reduced. So what is 14 minus 6? The answer is 8. Yeah, 8. 14 minus minus 6. So 4, 8, yeah. So meaning here also the bigger will go, they're going to remain with 8 hydrogen ion. Then we come to H2O. We have 7 water molecules. Here we have 2 water molecules. So the smaller will go, the bigger will be reduced. You remain with 5 H2O. Again, we check, we have 6 electrons and then 6 electrons will come. So meaning what is common, everything has disappeared. So what we do now is to rewrite. This is now 8 hydrogen ion plus Cr2 O7 minus. Then this is also plus 2HNO2, giving us 2N O3 minus, then plus 2Cr 3 plus, then plus 5H H2O. So now let's check if everything is okay. We have 8 hydrogen here plus 2, which is 10. This side we have also 5 times 2, which is 10. We have 2 chromium here. We have 2 chromium there, which is okay. When it comes to oxygen, we have 7 plus 4. 2 times 2 is 4. Plus 7, that's 11. This side we also have 5 oxygen here. Plus how many? What is 2 times 3? This is 6 plus 5, 11. So balanced. Then we come to nitrogen. We have 1 nitrogen here. Oh, sorry, nitrogen 2 here, nitrogen 2 there. So everything is balanced. So in this case, and presence of hydrogen ion is telling us to see that the reaction is in acidic medium. So acidic is done. Now we go to basic. So basic medium, remember what we say. So basic medium, the last part. So remember for basic medium, we basically add appropriate number of hydroxide ions. So we have 8 hydrogen ion. We're going to add 8 hydroxide. So we say here will be 8 hydroxide ion plus 8 hydrogen ion, which is already here. Then everything will be plus Cr2 O7 minus, then plus 2H NO2, producing so I'll just do camera like this to create space, producing 2 NO2, NO3 minus, then plus 2 Cr3 plus, then plus 5 water molecules. So after we put this one, we know that water will be formed here. So we're going to get 8 water molecules, then plus Cr2 O7 2 minus, then plus 2H NO2. This will give us 2N O3 minus, then plus 2Cr3 plus 5H2O. Yeah. So we have formed water here. 8 water molecules and then 5 water molecules. And we know that we have something in common again. We have water here and water. So the 5 water molecules will go, the 8 will be reduced. What is 5 minus 8? 3. So here we have remained with 3H2O. So meaning our new equation will be 3H2O plus Cr2 O7 minus plus 2H NO2, okay? Then this is 2N O3 minus, then plus 2Cr3 plus. So now we have to check if everything is okay. So remember, for basic is very simple. We just focus on add the hydroxide ion. Water is formed, cancel out what is common, then summarize. So when we cancel something, you have to check. So we have how many hydrogen here? We have 3. So we said added plus how many hydroxide are on this side? Okay, something. So we left out 8 hydrogen ion here, which is 8 hydroxide. Okay, so even here we say 8 hydroxide. Let me just write it properly here. It's going to be 3H2 plus Cr2O 7 minus, and then plus 2H here. We are getting this will be 2N O3 minus, then plus 2 Cr3 plus, then plus 8 plus 8 hydroxide ion. So we have 3 times 2, this is 6, plus 2, 8 oxygen here. 8 hydrogens. Here also 8. Let me just make it very, very clear here what we have. So what we have, let's just make it so simple. From here, we have 8 hydroxide plus 8 hydrogen ion, then plus Cr2 O7 minus, then plus 2H NO2. So because of space, we are going to do this. Then plus 2 NO3 minus, then plus 2 Cr3 plus, plus 5 H2O, then plus 8 hydroxide ion. So we have added hydroxide ion to both sides, but we know that water will be formed here. So when water is formed, we get 8H2O plus Cr2 O7 minus, then plus 2H NO3. Because of space, we'll do this. We have also H2NO3 minus plus 2Cr positive 3 plus 5 H2O plus 8 hydroxide ion. Okay, so we know that something had to cancel. The 5 water molecule go, the 8 will be reduced to 3H2O. What else has to cancel here? I think nothing else. So just that. Now summarize back the reaction. So this is 3H2O plus Cr2O7 2 minus plus 2HN. So this is 2, 3 here or 2 here. Okay, 2. We are getting, because of space, we can do that. 2NO3 minus. Then this is plus 2Cr3 plus, then plus 8 hydrogen ion, hydroxide ion. So we check, we have 3 hydrogen here plus 2. We have 6 hydrogen plus 2, we get 8. How many oxygen are here? This is 7. 7 plus 4, that is 11. 11 plus 3, that is 14. How many are here? We have 2 times 3 is 6. 6 plus 8, 14 balanced. We have 2 chromium, also 2 chromium here. So everything is okay. So just put state symbol. This is liquid. This is aqueous. This is also aqueous, and then aqueous, meaning we are done. Okay, so this is how it is done. So hopefully this was helpful. So what to do, just watch the video as much as you can. So the video will be available on YouTube, but what you do if you didn't attend the previous lesson, I'll put the link of the video in the comment section. We have to watch that one before we proceed to this. So this is where we end for today. Have a nice day and see you again.